Very good morning to all of you. Yesterday we had started with this particular problem and we were able to complete the first proof of the first bit, that is AB into K transpose is equal to U, right? So we will be uh, we will be proving the next identities in the row, that is the second one, B is equal to AL into K transpose, and the third one, CB is equal to minus BL transpose. So let us see one by one. So let us have a quick recap of the first proof that we had solved yesterday. So this was the graph, oriented graph, which was given to us in the problem. And with the help of this graph, we can see that there are three buses here, physical buses, that is 1, 2, and 3, which are represented by the nodes 1, 2, and 3. Similarly, there is a reference node 0 which is provided, and these are the elements which are given in the problem, that is 1, 2, 3, 4, and 5. Also, we had seen that all the orientations are given in the problem itself. That is, the directions of all the elements are already given in the problem. So we need not change any direction as per our wish. Then the next step that we did was first to draw the tree and co-tree. So you can see here we have drawn the tree and co-tree. So for tree and co-tree, what do we require? We require branches and link. So for branches and link, then what we did, we written the complete set of the formulas, that is total number of elements 5, total number of node 4, branch formula we have n minus 1, that is 4 minus 1, that is equal to 3, and similarly we had formula for L, that is link E minus B, which is 5 minus 3, that is equal to 2. Then we were supposed to identify the location of the branches and the links in the problem. So we did identify the location of the branches and the link. We have already stated the conditions for identifying the elements of a given graph as branches and link. The condition we will repeat once again. The first condition is that while selecting a branch in a tree, all the nodes should be present, and at the same time there should be no closed path. So these are the two rules that we have to follow while selecting the branch and link. So link are the fictitious element by closing which there is a formation of a closed loop. So there will be a formation of a closed loop when we close a link. So that's why we have chosen 1, 2, and 4 as branches. And ultimately, if 1, 2, and 4 are branches, the remaining two elements, that is 3 and 5, that will be links. So this we have seen yesterday, and then with the help of this, we have written our element node incidence matrix. This matrix is our element node incidence matrix. So first we need to have the element node incidence matrix, and once we have the element node incidence matrix, then we can make the bus impedance matrix out of it. So this is the element node incidence matrix. A dot, we have also cross-checked this matrix that summation of all the rows should be equal to 0 as per the KCL law. So Kirchhoff's current law we have stated, because we have considered the nodes, and at one point if we consider, then the summation of incoming and outgoing current should be equal to 0. So that is the principle that we have applied here, and we have checked whether the summation of all individual rows are equal to 0 or not. If it is equal to 0, then our A dot matrix will be correct, and we will be able to proceed further towards the solution. Next, after finding this A dot, it's easy for us to find out A just by eliminating the reference column from A dot. So we have eliminated the reference column from A dot, and we have written A here. Now the important part here is that we have to make partition of this A, partition in between branches and link. So we know that the 1, 2 and 4 element are branches and 3 and 5 are links. So we have made a partition in between this, and this portion of the matrix will be called as AB, and the lower portion of the matrix will be called as AL. B stands for branch here and L stands for link here. So in this way we got the AB and AL matrix. Then we have found out the K matrix. For K matrix we have to draw the graph once again, but here I have not drawn the graph. You in your copy you have to draw your graph and then identify the paths out of the graph and then write the K matrix. So in this way we have written the K matrix also. So the leftover parts we have to simply substitute by 0. So in this way we have obtained AB as well as K. So once we have obtained K, it's easy for us to obtain K transpose, and then in this way we have proved our first identity, that is AB into K transpose is equal to U. So far we have did all these things in the previous topic, in the previous lecture. Now we are going to proceed ahead and solve the second identity. The second identity is BL is equal to AL K transpose. So out of this we have already AL and K transpose available with us. Now we are in need of this BL matrix. So what is B? B matrix initially is the basic cut set incidence matrix, and when we partition this basic cut set incidence matrix, we will get two portions. The upper portion will be B suffix B and the lower portion will be B suffix L. We are interested in the lower portion, that is B suffix L, and once we get this BL, then we will be able to prove this second identity, that is BL is equal to AL into K transpose. So for that we have to draw the graph once again. We have to okay, let me make it correct here. So this matrix needs a correction. -1, 0, -1 first row is okay.
Yes.
Apply this, you will get 1 0 0 0 1 0 and 0 0 1. That will be your unity matrix, and that will prove your first part. So please make these corrections. Yesterday there was some error in this, so if errors will be there, you will not get the answers. Okay. So let us solve the next identity now. So the next identity, in order to solve the next identity, what do we require is we require basic cut set incidence matrix. And in the basic cut set incidence matrix, what we have to do is we have to take the lower portion. The lower portion is BL, that will give you. So we are going to draw the graph here. So this is our graph which we will be using, sorry, tree and co-tree which we will be using. And now here we are going to write our basic cut set incidence matrix. So here we are going to write our basic cut set incidence matrix. So this matrix is denoted by the letter B. So let us check how many basic number branches. And here the number of branches are 3. So the basic cut sets will be 3. So let us write the basic cut sets. So the basic cut set will be related to the branches. So branches are, you know what are the branches. So we have 3 branches here in this problem, 1, 2 and 4. So we need to cut the cut set according to this and give the names. So let us make the cut sets and give the name. So the first cut set that we will cut will be for 1, right? So for 1, if we want to make the cut set, it will be in this way, because we know that how to cut a basic cut set. While making a basic cut set, only one branch should be there for which you are making the cut set, and the other should be links, right? So this is the concept of the basic cut set. So this, in this way, we are going to cut 1, and we are going to give the name A to this basic cut set, which will be obtained by cutting 1. Then second will be for 2. So let's cut 2. So 2 can be cut in this way, and as the direction of 2 is in this way, so the direction of the branch will be also in this way. Then next is 3. So 4. So 4 we will be cut in this way, and the direction is here. So that's why we will put the direction in this way. So this will be C. So in this way we have cut the various cut sets. So we will write the entries of the cut set. So A is equal to 1, 3, 5. Similarly, B also is equal to 2, 3, 5. And C is equal to 4 and 5. See, remember this, that whenever we cut the basic cut set, minimum number of links should be cut. If minimum number of links are getting cut and you are cutting maximum number of links, then that cut set will not be treated as the proper cut set. So these are the basic cut sets that we have cut, and with the help of this, we have to write the matrix. So let us write the matrix. The name of the matrix is B. So B is equal to 1, 2, 4. These are the branches, and then 3 and 5. These are the links. So 1, 2, 4, as these are the branches, we have to write it first, and then we have to write the links. So 3 and 5 we have written after that. Then we have to write the basic cut sets here. So basic cut set, we will start with A, then B, and then C. So these are the 3 basic cut sets that we have cut. So one by one we will fill the entries, and we are going to complete our basic cut set incidence matrix. So you know what is the procedure. So procedure is, first we need to check what are the common points between those particular elements. So when we go to the basic cut set A, so A elements in the entries in this A set is 1, 3 and 5. So we have to check what is common between 1, 3 and 5. So if we are not able to get anything common in between 1, 3 and 5, we have to consider any of the point, that is either starting point or ending point, and we have to choose the shortest KCL path. So let us check that. So I will choose this point A as the reference point, and now see, we have cut the basic cut set A with respect to 1. So this 1 should be always positive. This 1 cannot be negative. Similarly for B we have cut 2, and similarly for C we have cut 4. So these 3 elements can never be negative. So this will be positive, and with the base of this we have to choose the direction of the other elements. So let us check that. So if I take this point node number A as the common point, then for this node number 1, this element number 1 is already positive. I have made already positive this. That means for this node number 1, this element number 1 is incoming. That means all the points that are incoming will be positive, and all the points that are outgoing will be negative, right? So we can see here this 3 is outgoing. That means this 3 should be -1, right? And this 5, you can see it's incoming. So this 5 should be +1. Is it clear, everyone? The cut set A, is it okay, everyone? Because in between 1, 3 and 5, we are not able to find out any common point, right? So we have identified this 1 as the reference point, and with respect to this 1, we are identifying what element should be positive and which element should be negative. So we have identified that 3 should be -1 because if we take this 1 as the common point, to this common point this element 1 is incoming, and we have already put this 1 as positive. Why? Because we cannot put this 1 negative. Why? Because for this 1 itself we have made this cut set, and we have put the direction same as that of the cut set direction, right? So that's why we cannot put this 1 as negative. So for this common point, node number 1, this element 1 is incoming. That's why all the incoming points will be positive and the outgoing ones will be negative. So we are interested in only these three elements, that is 1, 3 and 5. Don't treat that we are going to this common point 1. So 4 is also outgoing, so we have to make the entry to 4 also. Never do such things, because we have not cut 4, right? We have cut only 1, 3 and 5 in case of the basic cut set A. We have cut 2, 3, 5 in case of basic cut set B, and we have cut 4 and 5 in case of basic cut set C. So that's why I have written this sets, so that you will be able to know which points should be entered and which points should be not entered. Okay, so this 3 is outgoing, that's why this 3 is negative, because for this node number 1 we have already considered incoming as positive. So 5 is incoming, that's why I had taken 5 as positive. Alright, is it clear everyone? Then we need to focus on B. So B, it's very simple. For the B we have 2, 3 and 5, and you can see that 2, 3 and 5 are having this node number 3 as common point in between these three elements. So as the 2, 3, 5 are having this node 3 as common, we need to check the common point as 3. So for 3, you can see this 2 is incoming, and we have already made this 2 as positive. That means whatever elements are positive to this point 3 should be positive, and whatever elements are outgoing to this 3 should be negative. So outgoing is 5, so I will put 5 as negative, and incoming is 3, so I will put 3 as positive. Is it clear everyone about the basic cut set B? This matrix is very important, because this matrix makes a lot of confusion to many of the students, and they end up with the wrong result. So don't do such things. I am just explaining the easiest way to enter the elements inside the basic cut set incidence matrix. And the last is C. So C, we have 4 and 5. It's very easy for us to note what is common between 4 and 5. The common point between 4 and 5 is node number 2. And for this, we have already made this 4 positive. So whatever is incoming to this node number 2, that elements will be positive. So we can see 5 is also incoming. So 5 will be also positive. So that's why we will put here 5 as positive. Okay. And rest of all the fields will be substituted by 0. So in this way, we have obtained our basic cut set incidence matrix. Again, as we are interested in BL, right? So for BL, what we have to do is, we have to make the partition of this matrix. So how the partition is made? Partition is made in branch and link. So the upper portion is branch and the lower portion is link. That's why this upper portion will be called B suffix B, and the lower portion will be called B suffix L. Okay, so we are interested in B suffix L, so I will write here B suffix L is equal to the matrix, that is -1, 1, 0 and 1, -1, 1. So this is B suffix L. Now let us see what was the identity that we were supposed to prove. So we were supposed to prove was this identity. BL is equal to AL into K transpose. Okay, so we already have AL available with us. We already have K transpose available with us. Now we have BL also available with us. So it's easy for us to prove this identity. So let's prove this identity. So the identity, second identity that we have to prove is BL is equal to AL K transpose. So LHS we have is BL, and just now we have written BL, so just let us substitute the value of BL. So we have just now substituted BL, so let me substitute the value of BL from here. So BL is this matrix. So BL is here available with us. Now let us find the RHS. So what is RHS? RHS is AL into K transpose. So let me write here RHS. RHS is equal to AL into K transpose. So let us substitute the value of AL as well as K transpose. So we have already calculated AL and K transpose. So let me substitute from here. So here we have AL. So we will substitute the value of AL from here. So AL is available from here, and then we will substitute the value of K transpose. So this two we had already calculated previously. So we will substitute both these values from their respective positions. K transpose so in this way, we had written the values of AL as well as K transpose. Now, when you multiply this, you should get the result as BL transpose. So, multiply this and reply the results, whether the BL transpose is coming or not. So, you can multiply it in your copy. Minus 1, 1, 0. The value should come minus 1, 1, 0 and 1, minus 1, 1. So if you will get this value, then this RHS will be equal to LHS that is given, and hence it will be proved. So you are supposed to make this multiplication and reply on the chat box whether you are getting the correct results or not. So please make it fast. Till that time I will switch to the third matrix or the third identity which is asked to prove. So the second one is done. Now let us go to the third one. So the third one is CB into K transpose. CB is equal to minus BL transpose. Answer not matched. Why answer is not matching? There must be some problem in multiplication. Please check it out. Otherwise, we will see this third part and then we will cross check it. Let's see this third part and cross check the results. Okay, so let's start with the third part, so that if you will get the BL transpose minus BL transpose equal to CB, then there is no issues with the BL. Okay, so let's start the third part. The third part is okay. Okay, fine. Let's move to the third part first and then we will see. For third part, we need to find the basic loop incidence matrix. So third part is basic loop incidence matrix. Basic loop incidence matrix is denoted by C. And for basic loop incidence matrix, we have to draw the graph once again. So let us, tree and co-tree once again. So let us draw the tree and co-tree once again here. So this is our tree and co-tree. We will slightly enlarge this. or you can keep it as it is also, no issues. If you will enlarge it, then you'll be able to draw the loops correctly. So first let us close this link 3 and identify the loop. So when you will close this link 3, what will be the formation of loop? Let us find it out. So when you will close this 3, you will have this type of loop. So your loop will start in this way, because we have already said when you will close the link, only that link should be present which you have closed, rest all should be branches, right? So we have reserved the name A, B, C for the branches. The next will be D for this particular one, and next is 5. So when we close 5, 5 loop will be in this way. Okay, so 5 direction and the loop direction will have to be same. So in this way we will have the loop, and this will be named as E. So let us first write the elements that will be there in D and E, and then write the matrix. So D will have the set 3, because we have closed 3, then only D has formed. So 3, then 2, 1. This will be the entries of D. Then for E, we will have 5, 4, 1, 2. So this will be the entry for the E. Now we have already understood how to put the direction or how to choose the +1 or -1. So it's very simple. The elements which are moving with the loop will be +1, and the elements which are in opposite direction of the loop will be -1. So let us write the matrix then. This matrix is given by C, and C is equal to 1, 2, 4, 3, 5, because 1, 2, 4 are branches and 3 and 5 are linked. And then we will write D and E here, because these are the basic loops. So only D and E column will come, rest columns will not come. So let us go to D. So for D, this 3 should be always positive. And what about 2 and 1? Let us check. So our loop is moving downwards and 2 is moving upwards. So 2 should be -1. Our loop is going upward, as well as the element 1 is also moving upward. So 1 will be positive. Next for E, we have 5, 4, 1 and 2. So 5, 4, 1 and 2. 5 will be always positive, because of 5 only you are able to draw the loop. So 5 cannot be negative. So 5 will be positive. Then 4. So with this green portion you can see the loop E. So E is moving towards left and 4 is moving towards right. So 4 will be negative, as it is opposing the direction of the loop. Then your green loop is moving downward, whereas your element 1 is moving upward. So 1 will be also negative. Then your loop is also moving upward and 2 is also moving upward. So 2 will be positive. Okay. So in this way we have made the entries of the D and E. Rest of the parts we have to put by 0. Then we have to make the partition. So this is the partition. This will be C, and lower portion will be CL. So upper portion, let me write the matrix. Upper portion matrix is 1, -1, -1, 1, 0, -1. And lower portion CL is 1, 0, 0, 1. So if MCQ based questions are asked, then a certain graph will be provided to you, and they will ask you what will be the value of CL, and they will give you 4 options. So once you calculate the value of CL or CB, whatever is asked in the problem, you have to then identify the multiple choice questionnaires that they have asked to you. Okay, so now let us prove the third identity. If your third identity is getting proved, that means uh, you have written all the matrices properly. Or else, if it is not getting proved, then there is some issues in any of the parts. So let us check it. So third identity is CB is equal to minus BL transpose. So CB is equal to minus BL transpose. So C. Okay, so we were proving this identity CB is equal to minus BL transpose. So CB we have written just now. So LHS here is CB. So CB is equal to 1 minus 1 minus 1 1 and 0 minus 1. So this is CB. So let us check whether this CB is equal to minus BL transpose or not. So first we need to find out BL. So we have already calculated BL in the previous part. So let us write the value of BL. So BL is minus 1 1 0 1 minus 1 1, or we will just copy it from here. So we have BL available with us. So I will just write here BL. So this is BL available with us. So if we write BL in this way, then what should be BL minus BL? So for minus BL, we will have to multiply minus sign to this complete matrix. So this will be 1 minus 1 0, then 1 sorry minus 1 1 minus 1. And if you will make this minus BL transpose, then this will be equal to 1 minus 1 0 and minus 1 1 minus 1. So let us check this minus BL transpose is equal to CB or not. So you can see CB is 1 minus 1, this is 1 minus 1, then minus 1 1 minus 1 1, 0 minus 1 0 minus 1. That means your identity is proved. So if you will find out wrong CB or wrong BL, that in short I want to just convey that if you will find wrong matrices, that is whether it is basic cut set incidence matrix or whether it is basic loop incidence matrix, because see what are the prerequisites to solve this next two bits, because first two bits were already covered. Second two bits, for second two bits, that is bit number 2 and bit number 3. Let me go back to the question. So bit number 2 and bit number 3, you want basic cut set and basic loop. So if your basic cut set and basic loop incidence matrix will be wrong, then you will not be able to prove these two identities. So I'm sure that there might be some multiplication problem in the second matrix, because you have calculated BL also correctly, your AL is also correct, your K transpose is also correct. So there should not be any problem to prove the second identity. So I request everyone to check out once again the multiplication, and with that you can prove this particular identity also. Okay, so please check it out once again. If at all there is any issues, we can get back and we can solve the problem. Okay, so in this way we have proved all the three identities. So here there is no space, so I will write here itself that identity we have already proved. So hence proved. So this was the third identity which we had proved first. Once we draw the graph, then we will be able to check which elements are to be taken as branches and which elements are taken to be taken as link. So before that, you need to check what is the total number of buses which is given in this problem. So if you will check the buses, we have already said how to identify the buses. In order to identify the buses, we have to check the numbers with the circle part. So how many numbers with a circle part is given here? So you can see here 1, 2, 3 and 4. So this is what is given to us. So there are total number of 4 buses and nodes will be one addition to it, that is the reference node. So physical buses are 4 and one more addition will be there as a reference node. So we will draw our graph in this way. So this will be our 0, this will be 1, this will be 2, this will be 3 and this will be 4. Next, let us check to which buses the generators are connected. So you can see here from the original diagram, the generators are connected to bus number 1, bus number 2 and bus number 4. So what we will do, first we will draw that. So generator to bus number 1, bus number 2 and bus number 4. Then also give them their respective numberings. So they have given this from generator to 1 arrow, that is 1. Then this they have given as 2 and this they have given as 3. Next, 1 to 2 there is a transformer, so just substitute by a straight line 1 to 2 and this is given as element number 6. Then from 2 to 4, so you can see 2 to 4 we have to keep in this way and the direction is from 2 to 4, right? So this will be 7. Then from node number 2 to node number 3, the direction is in this way and the element is 5, and from 4 to 3 it's coming in this way direction and this is given as 4. Alright, so is it clear everyone how I have drawn the graph with the help of the power system? So this is how we make the graph as simple as possible. Once you are done with the graph, what you have to do is you have to write the total number of elements, total number of nodes, total number of branches and total number of links. So total number of elements, can anyone reply? What is the total number of elements in this case? In this case, what is the total number of elements? Very good. So total number of elements is 7.
7, sir. 7.
What about nodes? Yes, what about nodes? How many nodes are there? Total number of nodes. Okay, very good. So total number of nodes is 5. Then what about branch? We have branch formula as n minus 1. So n minus 1 means 5 minus 1, that is 4. So total there should be 4 branches. Okay. What about link? We have E minus B, that is 7 minus 4, that is 3. So in short, what we can say is there should be total 4 branches and there should be total 3 links. Now it's a big challenge for us to which elements to be considered as branch and which elements to be considered as link. Okay. So which elements are to be taken as branch and which elements are to be taken as link? We have already stated what are the conditions. Conditions are that when you select branch, then no closed path should be present and all the nodes should be present, and preferably try to check the condition that first elements are to be taken as branches or not. If you take first all the first elements as the branches, whether the conditions are getting satisfied or not. If it is getting satisfied, then go with that only. If it is not getting satisfied, then apply the rule and then check which elements are to be taken as branch and which elements are to be taken as link. Okay, so see the first here, as we have four elements are to be taken as branch. So let us consider 1, 2, 3 and 4. So if we take 1, 2, 3 and 4 and just eliminate this 5, 6 and 7, let's see whether our rule is getting satisfied or not. So the first rule is that all the nodes should be present. So yes, all the nodes are present if you take 1, 2, 3 and 4, and there should be no closed path, right? So yes, no closed path are also not getting formed if you take 1, 2, 3 and 4. So what we can do is we can take the branches as 1, 2, 3 and 4. This makes our numerical simpler. So 1, 2, 3 and 4 we will be taking as branch, and of course if we take 1, 2, 3 and 4 as branch who are linked, then link will be 5, 6 and 7. So when you show this branches and link to your problem, then the system that makes us will be tree and cotree. Okay, so this was graph. Now we are making tree and cotree with the help of graph. So let us do that. So 1, 2, 3 and 4, and this is the reference node 0. So we are taking element 1 as branch, so that's why we will draw by the dark line. Then element 2 also branch, element 3 also branch, and element 4. Just check the directions. You don't make the direction as per your choice. Okay. Then the links will be by dotted line. So this will be 5. This will be 6. This will be 7. So all the three identities that we have checked, this has to be proved by you. This we are taking today. Today is 10/4/2021. Okay. So I hope you all, I'm just correcting it. Is it correct now? Okay.